Hello people, welcome to DoubtGo. So I'll be covering the video for robotics for mechanical End Sems. Introduction: Robotics is the art, knowledge base and the know-how of designing, applying and using robots in the human endeavors. Robotic systems consist of not just robots but also other devices and systems that are used together with the robots to perform the necessary tasks. Definition of robot: it is a computer controlled machine that is programmed to move, manipulate objects and accomplish work while interacting with its environment. Industrial robot: it can be defined as number of rigid links connected by joints of different types that are controlled and monitored by the computer. There are 4 levels of industrial robot. Manual manipulators perform fixed or preset task sequences, playbacks, repeat pre-programmed fixed instructions. NC robot, numerically controlled robot, carry out tasks through numerically loaded information. Intelligent robots perform through their own cognition capabilities. Difference between robot and crane: basically robot, in robot the computer that runs the program controls the robot, whereas in crane the human operates and controls the actuators. And there is one more difference. It is like if the program is changed, the actions of the robots are changed accordingly. But in crane, a simple manipulator cannot do this without an operator running it all the time. Now coming to the characteristics of industrial robot. Repeatability: it is the replication of motion within some specified precision and tolerance. Coming to RCC, it's remote center compliance. This device helps pull the hand or tool into the required position by acting as a multi-axis float. You can see the diagram, you can like easily judge what is it. Characteristics of industrial robot: like there are many things in this, you can just pause and see. These are the important things you have to remember: manual control device, automatic control system, safety interlocks, speed of operation, computer interface. Components of industrial robot: there are 4 components of industrial robot. One is mechanical unit, then the other is drive, controlling system and tooling. Yeah, you can see the diagram. Mechanical unit: basically a mechanical unit, like you can see the hand of a man. It is the same thing, same work which like arm. Okay, so basically it refers to the robot's manipulative arm and its base. Coming next to drive, it is very important component of the robot, which is known as drive system. It supplies the power which enables the robot to move, the same way our stomach and digestive system do. The other is control system. Control system is like it's a controller, brain of a robot. Its main work is like communication and information processing device to initiate, terminate and coordinate the motions and sequences of a robot. Coming to tooling. Tooling, you can see this diagram. This is tool center point diagram, and we will discuss it later, but I will discuss it now only. So tooling is manipulated by a robot to perform the functions required for the application. Okay, talking about tool center point, basically it is located either on the robot or on the tool. So what it does is like it can be specified in Cartesian, cylindrical, spherical, etc., like different coordinates depending on the robot. As tools are changed, one often reprograms the robot for the TCP. These are the tools which can be used. Okay, like there are many tools, we can just replace it. Talking about the sensors, the same like the neural network in the human body, there should be some sensors in the robots. So there are different type of sensors, tactic sensors, and like different type of sensors. We'll talk about in a later stage. So this is about a robot manipulator. So in robot manipulator, basically it is the similar parts as humans chief manipulators, like the arm, the hand, the same thing which is replaced in the robot. This is called the robot manipulator. Talking about the terminology, so there are links. Basically these are solid structural members and joints which can be like which are movable couplings. Yeah, okay, movable couplings. Okay, coming to a degree of freedom, so this is number of independent movements with respect to the base. There are 6 degree of freedoms in a robot, like 7 degree of freedoms. It depends on robot to robot. Orientation axis, basically there is a term like roll, pitch and yaw. In it's like during the forward movement of the robot, like if there is a movement, when you can see from the top direction there is a movement, the movement is in like called as yaw, and watching it from the front end, it's called the pitch. Okay, and like if it is rolling, so here it can be like the roll is like when you see it from the vertical end. Okay, accuracy, precision and repeatability, you would have heard this before as well. So accuracy is like how close the arm will be when it comes to the desired point. Precision is defined as how accurate you are. Okay, and repeatability is like how accurate in the same position can be reached if the motion is repeated many times. Talking about this speed and stability and workspace, so workspace is like, we also call it work envelope. Like a robot can only work in a specific area in which it can move. This is called workspace. Stability refers to robot motion with the least amount of oscillations, and speed refers to either to the maximum velocity that is achievable by the tool center point, TCP, or individual point joints. Payload is like a load which can be carried by the robot. Okay, and it still remains within its specifications. Reach is called like, reach is the maximum distance of a robot can reach within its workspace. And settling time, like it is the time required for the robot to be within a given distance from the final position. Robotic sensors are used to estimate a robot's condition and environment. These signals are passed to a controller to enable the appropriate behavior. There are types of robotic sensors, exteroceptors or external sensors, which are attached externally to the bots, and proprioceptors or internal sensors. These are fixed or they are jumped on the bot, in the bot. Proximity sensors, we should remember these because these can come like they can ask like various examples of sensors. So these basically proximity sensors sense and indicate the presence and position also without the physical contact, so they can detect the position without touching. Talking about the range sensors, it is implemented in end effectors of a robot to calculate the distance between the sensor and the working part. Tactile sensors, it is the sensing device which specifies the contact between an object and sensor. There are two types of tactile sensors: touch sensors and force sensors. Touch sensors, basically like you can touch them and they can sense it, and force sensors, they can measure the force during the load and unloading. These are the difference between these two sensors. Light sensors, it is used to detect a light and create a voltage difference. Sound sensors, these detect the sound and return a voltage proportional to the sound level. Heat sensors, these help robots to determine if they are in danger of overheating. Talking about robot programming, A robot program can be defined as a path in space to be followed by the manipulator, combined with peripheral actions that support the work cycle. And these peripheral actions involves closing and opening of gripper. Gripper means the hand of the robot, performing logical decision making and communicating with other pieces of equipment in the robot cell. There are various techniques in robot programming, and there are different methods for entering the programming commands into the controller memory. So these are the basics: programming, online programming, lead through programming, walkthrough programming, offline programming, task programming. So that's it, guys. If this video helps you in any way, just click like and share with other mechanical students. It will help them as well, and subscribe our page. Thank you so much.